Look at your smartphone. This pocket supercomputer, right here in your hand. Now picture a future archaeologist, 5 millennia from now, sifting through the rubble of our civilization. They unearth this device, a sleek, black rectangle. Its power source dead, its language indecipherable. Such an object would defy their textbook timelines. Experts might label it an anomaly. Perhaps they'd call it magic, an impossible artifact, thousands of years ahead of its era. Yet it wasn't sorcery. It was physics. We've been fed a comforting lie. The myth of linear progress, cave to wheel, steam to silicon. A neat, predictable ascent. That narrative is a fantasy. It ignores the inconvenient truths. History isn't a straight line. It's a spiral, flashes of profound understanding, followed by societal loss, then painstaking rediscovery. We constantly relearn what was once known. Tonight, we're shattering that myth of uninterrupted advancement. Prepare yourself for a journey through discoveries that appeared thousands of years too early, not as isolated curiosities, but as fully integrated, functional systems. We're going to expose lost desert cities with sophisticated air conditioning, automated water management, and urban grids so meticulously planned, it took advanced LiDAR and AI-enhanced mapping to even grasp their impossible precision. Welcome to our first deep dive. We're moving beyond simple artifacts into infrastructure. Imagine you are standing on a desert plateau, sun blazing. Look closer at the immense blocks forming the foundations, the walls. These aren't rough-hewn stones. We're talking colossal, multi-ton slabs, some weighing as much as a small apartment building, cut with astounding precision. Visualize massive blocks, 20 feet long, fitting so seamlessly you can't slide a razor blade into the joint. Tolerances of less than a millimeter across spans the length of a football field. Consider building a skyscraper where every exterior panel snaps into place with microchip exactitude. This structural integrity defies textbook assumptions. The easy theories? We hear them all. Ancient astronauts with plasma cutters, Atlantean engineers wielding forgotten energy, or pure sorcery, conjuring perfect angles from solid rock. It's a wild menu designed to explain away the inexplicable. But this isn't about magic. It's about applied physics. Consider a modern concrete bridge. It expands in heat, contracts in cold. Engineers design for this. Now, apply that understanding, not just to using material, but to extracting it. They didn't need laser grids. They could have leveraged controlled thermal shocking, superheating a fracture line, then rapidly cooling it for a clean break, or high-pressure water, exploiting natural micro-fissures, creating a geological-scale cutting mechanism. Think how a modern water jet slices through steel. Imagine that principle applied to quarrying. They understood the material's crystalline structure, its breaking points, and how to manipulate them with remarkable control. So the capability existed. The methods, while incredibly demanding, are rooted in principles we grasp. The true mystery isn't, could they achieve this, but why? Why invest such monumental effort, such staggering precision into basic construction? The economic cost, the logistical nightmare of quarrying, moving, and placing these perfectly cut behemoths for structures that seem merely functional. This implies profound societal value, perhaps a critical functional necessity. We're only now deciphering. Their motivation wasn't spiritual. It was deeply practical, perhaps economic. The real question remains, why did this incredible knowledge fade into oblivion? Now shift your perspective. Imagine standing in a blistering desert, 120 degrees Fahrenheit, sun relentless. But then you step inside. It's cool, genuinely comfortable. Lush gardens thrive, fresh water flows. We're talking entire ancient cities deep in arid zones functioning as fully integrated climate-controlled environments. A unnamed smart home experience, thousands of years too early, scaled for a population. Oases, built where only sand should have been. How? The easy narratives speak of divine intervention, secret rivers conjured by forgotten gods, and perhaps some ethereal energy, a mystical hum hydrating the land. Fantastical explanations for a reality defying our historical timeline. We love a good miracle. However, let's strip away the myth. This wasn't supernatural. It was thermodynamics. Picture ancient engineers, masters of heat transfer. They designed elaborate subterranean aqueduct systems, precisely angled, tapping distant water sources, moving it via gravity. Then, massive evaporative cooling towers. Think of a giant passive air conditioner, hot air drawn in, passing over water-soaked surfaces, cooling, then sinking into the city's core via the Venturi effect, creating constant cool airflow. Coupled with multi-layered insulation and passive solar chimneys drawing stale hot air up and out, these cities were colossal, self-regulating environmental machines. It's the same science that cools your body, or a clay pot, keeping water cool, just amplified to an urban scale, powered by sun and earth. Capability and understanding were there. The real puzzle, therefore, isn't how they achieved it. It's the monumental cost, labor for vast underground networks, the constant battle against sand, evaporation, and mineral deposits fouling the systems. Every day was a fight against entropy. What was the tipping point? Perhaps a societal shift or environmental catastrophe made the immense, continuous maintenance of these astonishing systems no longer economically viable. It represents a staggering investment, a fragile balance that eventually tipped. Consider a map, a vast, empty desert expanse, labeled for centuries as a featureless blank spot. Nothing to see here. Yet, our remote sensing scans revealed an impossible truth. Beneath miles of shifting sand, hidden from every human eye, lay a perfectly gridded city, streets, plazas, monumental architecture, all meticulously planned. Discovering this feels like finding a lost metropolis, not in some forgotten jungle, but directly under your most familiar urban park. Easy explanations surface immediately. Desert mirages, satellite glitches, perhaps some fantastical ancient cloaking technology, finally failing. The old human-drawn maps, after all, simply showed nothing. How could they have missed it? Modern technology acts as a time machine here. We deployed LiDAR, light detection and ranging. From an aircraft, millions of pulsed laser beams fired down, penetrating the sand and sparse vegetation. Each beam reflects off even subtle changes in elevation, recording an exact distance. Think of it as a digital sonar, mapping the Earth's hidden contours with light, building a colossal 3D point cloud. Then, AI algorithms meticulously sift through that raw data, stripping away the noise of millennia. What emerges isn't a blurry outline, it's a digital ghost of a city. Urban planning, precise and undeniable, street by street, foundation by foundation. Proof of an advanced civilization where only emptiness was thought to exist. The fundamental question, then, isn't if it existed, it's why it vanished. What catastrophic event, or perhaps what relentless, slow societal decay buried an entire advanced settlement so thoroughly that not only its physical presence, but its very memory was completely erased from human history? Why did it become a blank spot, even in the collective consciousness? Look closer at the digital ghost we unearthed. This wasn't merely a grid of streets and foundations. Our deep, penetrating scans revealed an entire urban system. Imagine a desert metropolis operating with a level of automation and resource precision that would make a modern, smart city planner. Take notes. We're talking automated gates, water distribution so precise it could ration a single household's daily supply, even what appear to be early vending machine food stations, all operating in an environment designed to be inhospitable to human life. The usual suspects immediately surface: some divine blessing, perhaps a hyper-advanced alien civilization with technology light years beyond our own. Fun theories, certainly, but our job is to find the physics. Look, this wasn't magic. It was physics. Picture the float valve in your toilet cistern. Simple, right? Water rises, the float lifts, the valve closes. Now, scale that concept up. We're talking pressure-activated valves, finely tuned, counterweighted mechanisms, and the elegant dance of fluid dynamics, all orchestrating precise water delivery across miles of desert. Consider it a vast, interconnected machine where human input was minimized through clever engineering. They didn't need miracles. They needed margins. Mechanical computers, simple arrays of levers and weights, could schedule resource flow with stunning accuracy. It's like a colossal, city-wide Rube Goldberg machine designed not for novelty, but for absolute, unforgiving efficiency. Here's the problem: the existential itch that remains. The sheer administrative and logistical overhead required to maintain such a complex, interconnected system without modern computing is staggering. One tiny failure in a pressure sensor or a counterweight mechanism could cascade, collapsing an entire district's water supply or defense system. Furthermore, the energy, the constant human labor required to monitor, reset, and repair this sprawling mechanical marvel must have been enormous. It's a miracle of engineering. Yes, but a fragile one, constantly teetering on the edge of its own complexity. Yet, this automated oasis, this marvel of ancient engineering, ultimately failed. Its intricate systems, designed for perpetual self-sufficiency, simply stopped. Not with a bang, not from invasion, nor by the earth shaking it apart. The city faded into an echoing silence, a slow, agonizing decay. Alternative narratives arise: a sudden, devastating plague, a cataclysmic shift in climate, perhaps even the alien architects deciding their experiment was complete and departing. But our scans, our core samples, the very architecture of its collapse, tell a far more chilling story. The mystery isn't, could they? It's, why didn't it spread? Imagine a brilliant tech startup years ahead of its time, but every single component is bespoke, handcrafted, and resource-intensive. This city was precisely that. Its water systems, its climate control, its automated defenses, they were custom-built, consuming enormous amounts of local, finite resources. Water tables dropped, mineral deposits, vital for complex alloys and mechanisms, were exhausted. Imagine the rising cost of maintenance. Every repair, every replacement part became exponentially more expensive as resources dwindled. The central governing body, once a beacon of efficiency, grew rigid, unable to pivot or innovate beyond its initial, perfect design. Scaling this technology proved impossible. Replicating it cheaply for new settlements or adapting it to changing environments remained out of reach. Internal political strife over dwindling resources and rising costs became inevitable, grinding the gears of progress to a halt. The ultimate tragedy isn't about alien intervention or divine wrath. It's the stark, brutal reality of economics and human nature. Even the most advanced technology and ingenious engineering remain utterly fragile when the underlying social and economic pillars crumble. Greed, short-sightedness, and the inability to adapt can doom the most brilliant of human endeavors. Look at your smartphone again. This device, a testament to our era's ingenuity, sits in your hand. Consider future archaeologists, 5 millennia from now, sifting through the dust of our digital civilization. They uncover our vast server farms, the ghost circuits of smart grids, and the global logistical webs that once bound our world. They will stare in awe. They will marvel at our magic, our seemingly impossible feats of connectivity and control. Yet, what conclusions will they draw about the economic margins, the political will, and the resource cost that kept it running? Will they grasp the intricate, often invisible forces of profit and power that sustained and ultimately fractured our own complex systems? The narrative of that forgotten desert city isn't just a tale from the past. It serves as a stark, chilling mirror to our present. We, in our own era, craft equally intricate, profoundly resource-intensive systems. We stand exposed to identical spirals of resource exhaustion and the inherent fragility of complex designs. History isn't a straight line. It's a spiral. Humanity remains perpetually just one turn away from rediscovering or catastrophically re-losing everything we know.